Good morning, everyone, and thank you for joining us today. My name is Alan Gonzalez, Vice President at Berkeley Nucleonics, and I'm excited to welcome you to today's session on next generation arbitrary waveform generation and the capabilities of our Model 686 platform. We really appreciate you taking the time out of your busy schedules to be here. So whether you're joining us from a research lab, a production test floor, a university, or an advanced R&D environment, our goal today is simple: to give you practical insight into how modern AWG technology works, why it matters, and how it can directly improve the quality and repeatability of your measurements. So over the past few years, we've seen signal requirements become dramatically more demanding. The engineers today who are being asked to generate faster transitions, wider bandwidths, higher dynamic range, and more complex modulation schemes, often all at the same time. So in many cases, they're doing that while trying to correlate simulation, lab testing, and real world deployment. So that's exactly the challenges that led to the development of the Model 686. So the 686 delivers 20 gigasamples per second with a true 14-bit vertical resolution and up to 10 gigahertz of analog bandwidth. So that combination is critical. It means you're not forced to choose between speed and signal fidelity. You get both, which translates into cleaner edges, lower distortion, better SFDR, and more confidence in the results that you're seeing on your scope or analyzer. So whether you're working in semiconductor characterization, quantum systems, photonics, RF, wireless validation, aerospace, defense, or high-speed digital tests, the ability to generate precise, repeatable, and complex waveforms is becoming a core requirement. So it's not even a luxury anymore. And that's where this platform really shines. So today's session is designed to go beyond the basic product overview. We're going to start with the fundamentals, obviously, and then I'm going to hand it off to my colleagues, Edgar and Amira, to show you exactly why this system is right for your setup. So with that being said, I'm going to pass it off to my colleagues and we'll go from there.
My name is Amira Sakudi, and I am an Associate Applications Engineer out of the East Coast office for BNC in New Jersey. And welcome to our webinar on the 686. We wanted to take a preliminary poll and see who in the audience currently uses or owns an arbitrary waveform generator. You can answer to the right of your screen. And next, we're going to go into the definition of an arbitrary waveform generator.
Now that we got that first poll question out of the way, I'm Edgar Guzman, one of the application engineers here at Berkeley Nucleonics. And I'm going to hand it off to my colleague Amira, who you met previously, and she can explain exactly what an arbitrary waveform generator is. Amira?
Thank you, Edgar. An arbitrary waveform generator, also called an AWG, outputs waveforms that are specifically defined point by point in memory, which virtually creates any waveform with precision. With an AWG, you can make almost any real-world signal.
And yeah, and it's literally, it depends on the R, but you can generally make almost any waveform you want, as long as it's, you know your distinct times and you know the amplitudes. Generally, in the past, they were made in programs like Excel or MATLAB, where that would generate the plot points for you. Modern arbitrary waveform generators usually will have a waveform editor or some software that allows you to do it, or you can even uh, import functions or equations that you derive from some sort of statistical application. But there are several other products that generally get confused when talking about arbitrary waveform generators, and that's function generator and pulse generators. First, with the function generator, generally the ARBs, especially the ones we sell here, they do have a function generator built into them. In the terms of the 686, it's a separate software that you can run. It's called Simple AFG, and I'll show that later on in a demo. So we have the two softwares. We have the True ARB, which gives you the full control over all the points of your waveform. So if you can make realistically any waveform as long as you stay within the confines of the sampling rate and the max amplitude. Then we have the function generator. You don't really have as much control over the points as you do with an arbitrary waveform generator, but they are far easier to use if you're going to make just a very like a standard sine wave, ramp, a Gaussian pulse. Those are all predetermined, predefined waveforms. Those are also accessible in our arbitrary waveform generator software. Um, but generally, a function generator can do most waveforms that are predefined, very typical waveforms, and they can also do pulses. But and that segues into our pulse generators. So the pulse generators have even less control over the waveforms. So we no longer have control over distinct points. A pulse generator is usually an on and off, whereas a function generator and ARB can have sine waves. So you have through time this specific point. A pulse generator is very different than that. It's generally you have the amplitude, how long your pulse or your square wave is going to be on, and how often you want that to repeat. So that's generally something that gets confused when we talk to some of our customers. They they ask for an arbitrary waveform generator, but realistically, they may only need a pulse generator. Um, they may ask for a pulse generator, and then they mention they may in the future need to do sinusoidal waveforms or something like that, or any type of different waveform. And then we generally, then we start talking about function generators and how much control do you need. Then we go to arbitrary waveform generators. We make all types of products that do all types of different waveforms here, even RF waveforms, which are generally sinusoidal. But so it kind of just depends on the application, and that's what we're here for, is to talk to our customers and kind of pinpoint exactly which model or which one of our products will work best for your application. So we'll get more into like the actual 686 in this webinar because that's what this is based on. But if you have any other questions about any of our other instrumentation, please feel free to give us a call or shoot us an email and we can answer those as well. So here we're going to talk about the traditional versus the next generation of arbitrary waveform generators. Generally, in the past, arbitrary waveform generators were extremely complex to use, usually having to derive whatever waveform you wanted to achieve before you actually put it onto the arbitrary waveform generator, whether that, as I said earlier, whether that be through an application such as MATLAB or any type of statistical application that can derive these really complex waveforms. So with the advent of the modern technology, we get a lot cleaner, easier to use, and I'll be able to show you later on when I do a demo of the unit sitting right next to me and show you how easy it is to not only create waveforms but edit them in real time, sometimes while the unit's running, sometimes not, depending on the complexity and what you're actually changing on the waveform, whether it be the vertical or sampling rate or timing, things like that. The modern AWGs have extremely high sampling rates. The 686, which we're talking about here, is 20 gigasamples per second with the 14-bit vertical resolution. So it's a unit that would be best used for people that need extremely fast and extremely accurate waveforms. It's actually one of our best pulse generators, um, given that it has in the probably I want to say like 100 picosecond rise time, so or even 70 picoseconds, kind of depending on some factors there and how you define the waveform. So depending on what your application is, you may not even need a 686 for more complex waveforms. You just may need it for the extremely high sampling rate so you can get a fast waveform. So if you need the high frequency data for whatever application you're doing, I know in some previous, I can't really talk about them, but they were they weren't interested so much in the shape of the pulse. They were interested in the high frequency data that was in it. So it just kind of depends on the application and you wouldn't like what part of the ARB, like what specification is more important to you. And then we get into things like system integration. Like the 686 is capable of being synced with other units. I want to say a maximum of four, but the data sheet has a better spec on that. That's just off the top of my head. So you get up to um, four units with eight channels. So that's um, I want to say 32. Quick math. And then that doesn't even describe the digital channels as well. Each eight channel arbitrary waveform generator, at least the 686, is capable of 32 digital channels on the back as well. So something to keep in mind in terms of integration into systems as well as scaling upwards for more channel density. I know channel density is a very big thing at every quantum computing show I go to. So it's something that our design engineers really kept focus on, and is the channel density. And then we have the complexity of the wave, not just the waveform itself, but the sequence of waveforms that we do. So we some researcher may have, when they're testing whatever their device under test is, they want to test it at very specific instances. So they'll have multiple complex waveforms or even multiple simple waveforms at varying amplitudes. And you can, I'll show you later the sequencer on the TrueArp software, but you're capable of going through sequences of waveforms, and you can even get more advanced using triggers or even software integration to pick which waveforms you sequence to. So it's very complex. And it kind of just depends on the application. And I'll show you a little more of that when we get into the demo. So here we're going to talk about some of the fundamental parameters of an AWG. The first one everybody knows, that's generally the one that gets asked about the most, and that is the sampling rate. So for the 686 specifically, it's one of its key specifications at 20 gigasamples per second. So the sampling rate is something that's extremely important because that allows you to have the much more cleaner waveforms, faster transitions, sharp edges, sharp pulses, and actually defined pulses. There's a lot of waveforms you can make with less sampling rate, but they may not be as defined. And some points may need to be interpolated to just fill in the gaps to get a clean signal because a waveform needs to be continuous. So generally, any gaps will cause aberrations depending on your sampling rate. So the higher the sampling rate, the cleaner your waveform is going to look. Now, when talking about sampling rate, we also have to talk about the bandwidth. That's another fundamental parameter, especially when you're dealing with fast rise times, transition times, modulation, and the purity of your signal. How much frequency data is actually being put into this waveform? How clean they are. So it varied. It depends on application, but bandwidth is generally one of the specifications we get asked about a lot, especially when we're dealing with communications or even sometimes, low power semiconductor testing will be asked about the bandwidth because they want that high frequency data, or they just want more data in their waveforms as they do their tests on their whatever product or research they're deriving at that time. Next up is the vertical resolution. Now this is the parameter that dictates how many points from 0 to max amplitude you actually have and how much control you have over each point. So with the 686, we have 14-bit vertical resolution, gives you extremely fine control over how your waveform rises and the points in time through your sampling rate, the small steps you can make. So you get much more clean waveforms, and it's just all the control. Yeah, the control is what separates it from a pulse generator or even a function generator to some degree. So once again, it depends on the application, whether vertical resolution is something that's important to you. That's very dependent on the application. Next, we have memory depth and sequencing. Um, that's something that's kind of hard to show off, but memory depth, obviously, pretty self-explanatory. How long is the waveform? How many memory points do you actually have? And I want to say on the 686, it's around 9 million is the max for a waveform. But once again, it depends on your application. Do you need the extremely complex waveform? Do you need all those points? Um, Do you need the sequencer? Could you get away with doing those complex sequences with smaller waveforms using the sequencer instead? I mean, these are all different strategies you can use, but the 686 is capable of the extremely long waveforms as well as the sequencing, so you have a lot of variety there, and the ability to kind of choose how you do your sequences and your waveforms. And then one thing I didn't touch on in the bandwidth, now that I look at it, is modulation. That's something I'll look at a little later in the demo. I may show it, I may show, may not show it. Yeah, we all know what amplitude modulation, frequency modulation looks like. But I know in the function generator specifically as well, there is predefined modulations that you can do on your waveforms. So that's something I'll be able to show you guys as well.
Now that we've gone over the fundamentals of arbitrary waveform generators, we want to ask everyone watching what specification is important to you when it comes to AWGs. You can answer to the right of your screen. This also ties in what industry you're in and could tell us a little bit about your applications as well.
Yeah, just throw your applications in the chat there. We're always happy to hear about you guys' applications. Thanks for answering that poll question, guys. We'll go through all that data later, and we always look forward to knowing about all you guys' applications and what specific specifications you guys are looking out for, not just for current products, but even for future products, and how our design engineers are gonna the path they're gonna go, and are they gonna go for more sampling rate, or are they gonna go for more vertical resolution? Yeah, market kind of dictates all that, right? So let's get a little bit more in depth to the 686. Previously, I was talking, more in general terms, even if I did mention specifications of the 686. As I said previously, the sampling rate is one of the key specifications of the Model 686. 20 gigasamples per second, real-time sampling. That's what allows you to get those extremely fast pulses and the high frequency waveforms, as well as just the extremely clean and pure waveforms. So that's one of the major draws for the 686. But we also have the 14-bit vertical resolution. If you do need higher, we do have other products, such as the 685. But 14-bit vertical resolution is still extremely high for the sampling rate we're dealing with. So that's another um, specification that our customers look at if they need extremely clean waveforms or extreme control over how their waveforms are generated and each point of the waveform. So as I said before, it all really depends on the application. Um, so I mean, you guys let us know some of those applications. So we'll see how that fits into some of the Model 686. I'm sure some of you answered vertical resolution. Um, Next, and I've talked about this, is the advanced waveform sequencer. Now, this is a feature that is on all of or at least this line of arbitrary waveform generators, whether that's the 686, 685s, the 670C, they all have the waveform sequencer. And you can do up to 16,000 waveforms, and that's something I will show off later when I'm doing the demo. You'll be able to see the sequencer. It's fairly easy to see. It's kind of what I use to determine which software I'm in. Because as I said earlier, the 686 has multiple softwares, but in terms of waveform generation, it has two separate softwares on it. That's the function generator and the arbitrary waveform generator. The arbitrary waveform generator has the sequencer on it, so it'll be very clear when I show you guys that later. The differences between those two GUIs. And then, much like the other arbitrary waveform generators, multi-channel synchronization and is a key factor in some of our customers' decisions with going for the 686, whether that be assembly line, quantum computing, where you need channel depth, especially when you're dealing with extremely complex waveforms. And the mixed signal capability. Each at least 8-channel unit is capable of doing 32 digital channels. The modules of those are on the rear. You can see those on our website. On the pictures, you'll be able to see the rear of the instrument. And with the multi-channel synchronization, you have access to all those channels and all synced together. so that you have essentially one large unit functioning 32 channels analog, as well as marker outs, all the complex triggering, the different sequences, each one has its own different waveform. They may all follow different sequences. It all kind of, it's basically the capabilities are almost limitless when it comes to like integration into multi-channel systems and the capacity for all the different types of waveforms and mixed signals. So just with the 686 alone, I mean, it is extremely complex, and it just even showing you'll see in the demo, like there's a lot of stuff that I have to remember to show because there's just so much that the 686 offers. And like, I'm really looking forward to showing you some of the capabilities of that. Also, feel free to shoot us an email, give us a call if you have a specific waveform, specific sequence for your specific application. Yeah, you let us know. We can try to duplicate it. If you have the waveform data and you want to see what it looks like on this unit, we can import it, and then I can send you oscilloscope images to show you exactly what that looks like coming out of the model 686. So yeah. All right, so here we have a table looking a little closer look at the advancements, as the title of the slide says. And we have, the categories of past AWGs, some of our current, AWGs or just other AWGs on the market. And then we have the model 686, and then just some, the very straightforward specifications, kind of highlighting how advanced the model 686 is. It is our newest arbitrary waveform generator with that 20 gigasamples per second. But it does kind of depend on your application. As you can see from the asterisk below, we do have the model 685, which does have a higher vertical resolution of 16 bits, but it doesn't have that sampling rate that the 686 has. So it kind of depends on your application, uh, as well as any of these other specifications. Just because something is we're advancing things, it doesn't necessarily mean that's something that you need. But it's nice to look at the 686 so you can see the capabilities of where we're at and where the technology is going. So it's very exciting to see the strides in how fast waveform technology, just creating waveform technology, how fast that's progressing, especially when you compare it like in this table to past AWGs and just even some of the current AWGs on the market. And to highlight some of these specifications specifically for the 686, I'm going to turn it over to Amira, and she can talk about a little bit more about the specifications of the Model 686.
Thank you, Edgar. First, we're going to start off with the amplitude. The 686 has up to 5 volts peak to peak into 50 ohms with plus or minus 2.5 volts hardware offset. 5 volts peak to peak into 50 ohms is industry standard for high performance AWGs, and it's important because modern experiments increasingly demand signal integrity at the point of use. To get into more of the interesting specs, the rise and fall times and minimum pulse widths. These two are very extraordinary and very fast for um, the market and other things that we compare it to. So the rise and fall time of around 70 picoseconds is very, very, very fast. And this allows for sharp edges and to create real world signals. These waveform generators must preserve the edge fidelity, not just the nominal waveform shape. And then again, the minimum pulse width of around 100 picoseconds, very narrow pulse, critical for timing applications that include gating or impulse like stimulations. And these two specs, the rise and fall time and the minimum pulse width, outperform most pulse generators on the market. So the 686 could be an alternative to if you have a very fast pulse application.
There is something else I would like to add, just specifically. This is specific for the 686s, and it's something I'm going to show in the demo. And there's a capability of the 686 to do overshoot tuning, and it's something I will show. So if you have those extremely fast edges, which this unit is capable of, and depending on impedance mismatches, you may have to, tune the rising and falling edge just so you get less of an overshoot undershoot. And that's generally something that in the past that would have been done through iteration or feedback. But I can show that that actual specification or the overshoot tuning on the 686 in the demo.
And let's take a look into some applications that we've encountered at BNC with our customers. For our customers in academia, we've seen ferroelectric measurements and also response characterizations. For ferroelectric measurements, and AWG is especially helpful to do the PUND method, positive up, negative down. And this will calculate the switching and non-switching currents. In response characterization, you can test materials and categorize them based on how they really react to a known stimulus that you create with the 686. These kind of applications have a need for precise, repeatable waveform and stimulus response. And the sampling rate and vertical resolution is what makes the 686 shine in these applications. For our customers in the business sector, we'll see integration testing, emulation of real operating signals during system validation. Specifically, if you have some kind of electronic prototype that you're going to be integrating into a larger system, you want to make sure that it operates how you want it to operate when it's given the signal that it would find in the real world. So you would test this with the 686 before you make it a part of a bigger system and you have a bigger problem. And the amplitude control, memory depth, and multi-channel timing of the 686 makes it stand out from other units. For our customers in the government sector, we see a lot of timing applications. It's the deterministic load jitter signal generation for time critical systems that makes the 686 very popular. The rise and fall times, as well as the minimum pulse width, sets it apart from any pulse generator. As Ed mentioned, also the overshoot correction and the multi-channel synchronization on analog and digital channels just makes it such a scalable unit. Next, Ed's going to go over a real-life demo of the 686 and all of the capabilities that it has.
Before I get to that, I would like to expand a little bit more on some of the applications we see. I mean, these are just some of them, and they are kind of broad because the uses of AWGs it's pretty vast or a large plethora of applications and research options. One thing that's not mentioned here, and that's generally one of our larger customer bases tends to be um, semiconductors, whether that is for the complex signals going into the different characterizations of different semiconductor properties, or the fast rising edges, or even just the ability to use a sequencer to throw in different types of waveforms and to see how um, the device you're testing, how that reacts to what you would think is a real world signal that may um, be generated through EMI or just random noise in your in the environment today. So that's where the arbitrary waveform generators are extremely useful in the fact that they're able to do those complex sequences and those extremely fast transition times to test the cutting edge semiconductors, whether that's memory chips or just other types of semiconductors, ICs. I can't really go in depth into that, but it kind of depends on what part of the semiconductor you're testing or which characteristics you're modeling. We also see a lot of use in optics and in terms of optical modulation using fast pulses. So using EOMs, that's one of the main applications, and that's generally for our fast rise time pulse is 765, but for our 686 because it is our fastest pulse generator It's even faster than the 765. Um, Even though it is an arbitrary waveform generator, it also, it is a our best pulse generator. And that's just some of the applications. We also have obviously some communications, not so much like we would with our RF stuff, but generally, if they're working in the lower frequencies, they may need some complex waveforms or even the digital signals for certain, certain characterizations. So it kind of like it's very difficult to talk about a few applications. There's just so many, and any of the engineers here and even in our East Coast can, if you see us at a show and you ask us about applications, we can talk your ear off because the amount of applications we have, we deal with, it's extremely fun. We also, we'll be going to a conference later in March, and we'll talk about that more later. So you feel free to come to the booth and tell us about your application. So we expand our knowledge there. And so always a joy to hear about the different uses for our product lines. Now it's time for the demo of so I can show you the GUI as well as some of the functionality of the Model 686. I am going to be doing it through remote desktops because I really don't feel like dragging my camera over. But it is extremely easy to use through the front panel as well. It has a a touch screen and buttons and things like that. And we can if you look at the images of the unit, you'll see what it looks like with its its front display on. Okay, so here we have, turn that off. This is the AFG. I'm going to close this and show you. So this system essentially is it's a Windows system. So it's running Windows 10, and it can be used as a computer. You can hook up a mouse and keyboard to it. In fact, I would recommend, if you're trying to do complex waveforms, to use a mouse and keyboard, because while the touch screen is great to use when you're doing small motions, it can be a little tedious. So but it can be used that way so that you have that ability to either do what I'm doing, remoting into it, or using a mouse keyboard, even hook a monitor up to it, and then you have it down so it's out of the way, and you can use it as your computer. So here you can see some of the softwares. Excuse my cough, please. Here we have the pattern generator. I can open it for you. I don't have a license for that on this specific unit, so you'll see a pop up saying it's in demo mode. So you are able to, actually look at the GUI and see what's going on, even though you may not have specifically purchased that option on your 686. So it takes a bit to load. Now you see demo mode, and there you go. That's the GUI for the uh, pattern generator. So you have the carrier data, the different types of clocks, whether it's custom, PRBS, you know, all these different options. I'm not overly versed in like this one, but I have used the pattern generator before. And then we have the transition data, so you can make your own complex patterns essentially. So let me switch to PRBS, and then you can do modulated as well. You can do burst. So there's a lot of complexity when it comes to how you handle um, the different patterns. And then here you have, you can pick what type it is. You can use symbols, transitions. So it just kind of depends on what you need to, even your output format. So it kind of depends on what you're actually going to do if you do need the pattern generator. That's something that you can look at on the 686, and some of our other arbitrary waveform generators have this software as well. So if you don't need the extremely high sampling rate, another ARP may be something that you're looking into. This also, you can do the different orders, you know, of PRBS signals. So now I'm going to switch over to, and this is the AWG. So this is the standard function generator that comes with the model, the 686, and comes with all of our arbitrary waveform generators of this class. So the models 670C and upward, they all have the simple AWG software. Their functionality is almost identical. It's just the speed at which you can do things and the voltage levels will differ. So here you have the standard, like I said, standard function generator. You have sine wave. You can do square, ramp, pulse. Pretty much, these are the standards. You can even do an arbitrary waveform um, built on um, any type of waveform you want. You have a little less control with this than you do with the arbitrary waveform generator, but you still have control. You can also import waveforms here or edit waveforms. You can see the list here. So you have complete control over the data on this system. So you can have a far longer list of waveforms here, depending on what you've created or imported. So let's just do something simple. So I'm going to set it to default, and that just sets it to how it is out of the box. You run it, you run the software, this is what you see. And so here we have frequency control. This is where it kind of differs from the arbitrary waveform generator. Um, the arbitrary waveform generator, you generally control the samples and the clocking. You do have control over the frequency, but a little math is involved unless you're using a parametric waveform feature, which is a really awesome feature I'll show you when I get to the arbitrary waveform generator. So let's just turn on this channel here and then output. And I'm going to switch over to, I have another remote desktop hooked up to an oscilloscope. So there it is. You can see just, standard sine wave. Let me zoom out here. And I can change some features here. Let me change the amplitude. So there, I increased it to 1.5 now. Let me go back to this scope here. And let me lower this. So, and as you can see, kept its shape pretty well. And you can do that in the function generator. You can change the amplitude as the unit's outputting. Some things you can change, some things you can't. Generally, most things are changeable. You can even add some internal noise. Let me see if I can do noise level here. Yeah, so now I've added noise. I can do less noise. And I can, let me show you this on the actual ARB. So here, I turn this on, and we have the screen over here that does show as close, as comparable as what you're actually going to see on the oscilloscope. So you get kind of understanding of what the waveform will more than likely look like. So we turn on the noise here, and you can see I've added internal noise. You can change this value on the fly, and you see this changes over here. So, and this is like for each channel as well. Each channel is independent. This one I could set to a completely different waveform, and it doesn't affect this waveform at all. There's also other functionality, whether that be triggering. You can do the external trigger, the trigger input. There's a actual physical button on the front that you can trigger, and there's the timer as well, and you can set the timer so you can tell it when to trigger. So if you have a test you want to do and you need it to trigger exactly 10 seconds from when you click it, it's something that you can do here. Let me see, then the max value goes up to, what is that, 100,000 seconds, something like that. So, it's pretty, a lot of leeway there. So I'm going to just do that. Right now, I'm not doing any triggering. And these are just, standard settings, clock settings. You don't really have as much clock control as you will with the arbitrary waveform generator. Given that it's a function generator, it is very reliant on knowing what the clock signal is because it's generating it through functions and through math. So then this unit in particular has 2 marker outputs. So I'm not going to really show those off. Everybody knows what markers are. It's just something you can use to sync or follow along with the waveform that's on the screen. So you have the 2 different channel marker outputs. And let me see. The function generator does have modulation right here. It's one of the built-in functions. So you can do, give me 1 second, let me drink some water. You can do different modulations, whether that's AM, FM, phase modulation, FSK, PSK. So these are built in and you can use these. Let me see what this looks like if I have that do modulation, turn that off, turn it back on. Switch on over. And now you can see it modulated. So it's fairly straightforward. Like I said, function generators, historically have been extremely easy to use compared to arbitrary waveform generators. I mean, you'll see just, when I go into the arbitrary waveform generator software, the UI is very, very similar. There are obviously some differences, such as I mentioned earlier, the sequencer is visible. So here you just have all the settings each channel independent. And I'm going to switch over to the arbitrary waveform generator. Let me switch this all back here. I can look here. We also have, the different functionality: sweep, burst mode. So, I mean, it kind of depends on what you want to do with the function generator, but it does have a lot of different functionalities that you may be able to use. You can change the load impedance to some degree to try to match your load, so your amplitudes kind of follows what it's supposed to be. Baseline offset, high limit stuff like that. Just a lot of standard stuff. The polarity invert. If you have any other questions about this particular software, feel free to shoot me an email, or any of our other engineers, and we can talk about a little more in depth about this software. But in the meantime, I am going to switch over to the TrueArb. Let me cancel that there and stop that and switch over. So it'll close that software and then it switches over to TrueArb. So this is the actual arbitrary waveform generator software. This is where you have the sequencer, you have control over your sampling rate, your clock. You basically have control over every aspect of a waveform. So it takes, it's loading it into memory. Windows, always slow. Here we go. So as you can see here, the big difference is we have this sequencer, right? So here I can add multiple sequences and then it keeps going. So it kind of, you may not need that many, you may need all of them. I mean, kind of just depends on the application. I can just get rid of all these and then remove selected. And we just have the standard here, and here's the waveforms, and you can see something here called parametric. And that's what I'm going to show you. And then here's all the controls you have over the waveform and the sequencer strategy, whether it reduces the waveform points, cuts the tail, cuts the head. We actually see a little more of that in the sequencer settings here. So you get a lot more control over how the system responds. If you have a waveform that's running too long or it's too short, how will it interpolate? Is the waveform too long compared to other waveforms in the sequence? Will it decimate it or cut the tail, hold fast? So generally it depends on how complex your waveforms are and the complexity of the sequence, but you do get a lot of control here. Then here's the device settings. As I said, you have control over the sampling clock. Triggers very similar. This particular unit has 2 triggers, so you can set the different impedances. All these settings, marker settings. Very similar to the AWG. And then other settings, just how long will you have to hold the button, things like that, and log files. So there's a lot of different options that for you to play around with depending on what you're doing. And then we have here is something that I was talking about earlier. This is the overshoot tuning. So I will show you. I'm going to make a waveform. I'm going to show you how this looks. So you can also change optimizations to be low noise, high linearity. You need flatness compensation. You may not care about those things as they do affect your waveform shape, but that may be something that's extremely important to your application. And you also have a correction offset if you need to offset depending on certain factors with how you're testing. So you have control over that as well. And then the baseline offsets and what the channel does when the waveform is over. Does it keep the last value? You set a custom amplitude and then polarity. And so these are just some of the settings you can go through. And let's actually get to making a waveform here. So here it's just a simple sine wave, but I'm actually going to show you this guy. So this is a parametric waveform. This allows you the ability to make a waveform in the arbitrary waveform generator that is almost as easy as making it in the function generator. So here I made it a pulse, but you can make it a sine wave as well. So here I'm just doing a really fast pulse. I said, what is this? 1 megahertz. We set the sampling rate. It will create all, and I can reduce this as well. So pulse width, duty cycle. I'm going to make this, let's say 500 pico. I still think that's 50%, right? Yeah. Okay. So we have control over the rise time, fall time, the delay, cycles length are generally controlled by how this creates the waveform, but you can dictate how that's done here. So you can tell it how you want to actually do it. Length, sampling rate, cycling, or how many cycles, the frequency. I'm choose this one because this, generally tends to work out best for pulses. And then wrap around, whether it will wrap around each pulse to create a frequency you need. So I'll commit this. And you can see it was just, I just went here to make it do parametric. You can call it however you want. You can make it part of the predefined. If this unit had digital, you could also make digital waveforms here. So that's some of the functionality. But this is one of the things that I like to point out the most because it makes it extremely easy to make a waveform in the arbitrary waveform generator. So now that I made it, you'll see the parametric waveform is here on the list. I select it. You go back to the parameter here, turn on the channel. I'm going to output. Let's see what it looks like. So let me zoom in. So as you can see, pulse. I can even change some of the voltages. That can't be done real time. You have to change the high-low when the unit's not outputting because you have far more control over the pulse or the waveform here, the arbitrary waveform generator. So it's basically creating the waveform as you're doing it. So now as you're looking at that pulse, I'm going to go to the channel settings and then go to the overshoot tuning. I'm going to play with it. And as you can see, I don't know, let me zoom in a little more there. Let's see. You can see that rising. Let me do this. Again. Right there. Back to this guy. And you can see as I play around with it, the overshoot, right? It's tuning. So that's without the tuning or just letting it go. And then I'm damping it here. And now I've damped the overshoot and undershoot. So that's one of the, and that's on the fly. I'm just literally, I can show you changing. I'm changing this just on the fly. You can even type in a value. You can, tell it how you want it to be optimized. So you have all these, these options. I can turn this off all while it's running. And then we go back to the oscilloscope. Let's see. There. So you see, nice clean pulse. This is a extremely fast pulse. Let's see, can I show the rise time here? So you can see the rise time is fairly quick. And this will get better with the faster frequency. I mean, arbitrary waveform generators, you're literally creating the waveform as you're going. So there are slight differences, but generally, you get extremely clean and very pure pulses or any type of waveform. So let me go back to the main unit here. Where is it at? It's right here. Okay. So, and then here we have channel 2, obviously. So each channel is independent with each other. The thing is, though, I believe when you add the sequences are not. The amount of sequences, that is not something that is independent, but you don't necessarily have to use the sequence. You can just take last or even just set it to 0, right? So it all kind of depends on what you need to do. These systems are fully remotable. I'm not going to click this because you'll be able to see IP addresses and stuff, although it realistically doesn't matter. Um, this is just a server, and it tells you the exact IP in which to remote control or even send Skippy. Actually, I can show you. So if I were to send Skippy commands here, you would see the actual commands pop up on this window, which is something, I think is actually pretty cool. You will need to know the computer's login information and then whatever, these have default passwords, but whatever password you set, just like, remoting into any other Windows-based system. Um, the license is what dictates the functionality on the unit. You may not need some things like the pattern generator, but that can be added later on through a license. And then we have calibration. This system can do diagnostic and self-calibration, and then even load factory default settings. So we have all the basics here. But in general, that's the main functionality of these and how easy it is to kind of use. You see, see a clock pulse here. You can also see if I can open this. Remote doesn't like this, so I gotta close that. Turn that off, and then do a waveform, and then let's see. I will just actually. The remote desktop doesn't like that corner, so I'm going to show you the actual software. This is the actual waveform editor, and it can be brought up in the software. It's just the remotes section for some reason doesn't like me touching that top corner. So this is the actual like waveform editor that allows you to make any type of waveform you realistically want. You can even do digital groups as well. So here you see the digital pod 0 to 7, so 8 bits, and you're able to make those waveforms or those patterns as well. But let's just go into, let's see, edit waveform. This should let's just pick a sine wave. So here you have some control over the period and the cycles. And if you wanted to change the length, you would do so before you go into this particular window right up here. So this is where you have all control over your waveform. If I were to pick other pulse, you can see here, it's just, all the different strategies. Or if I did custom, this is where you can see the depth of like exactly what you can do for the waveform. This is literally every point. It tells you exactly what point in time that is. So roughly every 50 pico, you can pick a value and tell it what to be. So, and this goes on for, and there it is. That's the point there. That's the actual pulse here. It goes on for how many points? 2047 points. So this particular waveform is that long. So I think we can do, And you can make longer waveforms. You can even, import here, whether that's from a file or a formula. You can even import formulas into here to generate your waveforms. So kind of, really just depends on what you need. There's not, there's more I could show, but it really is extremely like a complex system. So it depends on your application. So if there's something specific you want to see, just, let us know and we'll be more than happy to show you the different functionalities and features of our arbitrary waveform generators, the 686, 685, or any of our other products. We're always happy to talk to our customers and just learn about what they're doing.
Anyone watching, you can come see us at APS, the Global Physics Summit in Denver, Colorado. We're going to be at booth 1327, and we're going to have a Model 686 with us. And you can watch us do a demo. You can see the interface with your own eyes, and you're not going to want to miss it.